Hello Year 12s. So we are moving on to the last part of current electricity, and that is sensing circuits. So in the previous lesson we did a potential divider where we said we can split the voltage based on the resistances we are choosing. Remember? So this was the circuit we used. We had the V in given here. We had two resistors R1 and R2, and we take the output from here. So this is what we saw in the previous lesson. Now the problem with this circuit is we will only get a constant output here. For example, say I had R1 and R2 the same, and say I was having 9 volt here. So if both the resistances are same, I will be getting half of 9, which is 4.5 exactly from here. What if I want something like, I want to vary the voltage between 4.5 and say 1. I want a voltage between 1 and 4.5. In such case, then what will I do? I can't use this circuit. So that is when we are going to use some we are going to use circuits where one of the component will not be fixed. There is something in that component that will change the resistance. Okay, so whenever we need a varying output, then one of the external resistors can be replaced by a thermistor, a variable resistor, or an LDR. Okay, what is the speciality between a thermistor, a variable resistor, or an LDR? All the three of them don't have a constant resistance. Depending on depending on which component we are talking about, the resistance keeps changing based on an external parameter. Okay, so whenever we want to have a varying output, then one of these resistors can be replaced by a variable resistor or a thermistor or an LDR. So how will it look like? So let's say I'm going to go for a variable resistor first. So in the case of a variable resistor, again I have a fixed resistor here, and then I'm replacing the bottom resistor by a variable resistor. So I have the V in and I have the V out here. Okay. Now, if anybody asks me why the bottom one and not the top one, feel free. Feel free, go ahead and change the top one instead of the bottom one. Okay. So, say this is the fixed resistor and this is the variable resistor. So fixed resistor, let's label it as V1. The voltage across the fixed resistor as V1 and the voltage across the variable resistor as V2. So what will happen here if I am increasing the voltage? So if the resistance, not the voltage, if the resistance of the variable resistor is increased, what happens? Whenever the resistance increases, what happens to the voltage? The voltage across the variable resistor would increase. So V2 increases. If I want a low output at some point, all I need to do is keep the variable resistor to a minimum. I will have less voltage across it. If I keep the variable resistor to a maximum, then I will have more voltage out of it. Then in the same circuit, I can connect the voltmeter in a different place. For example, I have a fixed resistor here, I have a variable resistor here, and then this time I have my V out here. Okay, so the same V in I am giving V1, V2. Now, as we have written here, if the resistance of the variable resistor is increased, what will happen? As we said before, V2 increases. But what you need to keep in mind is, now V2 is not your output anymore. Okay, your output is V1. So if they ask you what happens to the output, what you need to keep in mind is that this is a series circuit. So V1 plus V2 should be giving you the total input because the voltage is shared. Now V2 increases, V1 is not changing. So what does that tell you? That means V1 should decrease. Okay, so read the question carefully, what they are asking you for, where the voltmeter is kept. And then based on that, you should say whether the voltmeter reading decreases or increases. If the voltmeter is connected across the varying component, then here, as the resistance increases, the voltmeter reading will also increase. If it is connected not on the varying one but on the fixed one, opposite happens. Here the resistance increases, yes, there the voltage will also increase, but because it is a series circuit and total voltage has to stay the same, the voltage across V1 will decrease. Okay, we have something very similar with thermistors also. Thermistors and LDRs, all of them actually act very similar. Okay, so the thermistors also, we can connect it in two ways. First, I'm going to show like how I connected the first part of the variable resistance. So I have a thermistor here. So first I'm connecting the V out here. Okay, and in the other one I'm connecting the I have the V in here, I have the V in here. Here, instead of connecting it across the variable component, I'm connecting it here. Okay, so thermistors, you know that the resistance depends on temperature. So what happens as temperature increases, the resistance of the thermistor will decrease. Resistance of thermistor decreases. Okay, so if, again, let's label it as V1 and V2 itself. So if the resistance of the thermistor decreases, what happens to the voltage across the thermistor? That will decrease. So V2 decreases. Here the voltmeter is connected exactly across the varying component. So whatever happens to the voltage there, the same thing happens there. Hence, voltmeter reading increases. Okay. Here what happens? As temperature increases, resistance of thermistor, again no change, decreases. Let's label this again as V1 and V2. So V2 decreases. But what is the problem here? The voltmeter is not across that. Again, as we wrote for variable resistor, as V1 plus V2 is equal to V in, V1 will increase. So voltmeter reading increases. Okay. So when you get an exam question, please be careful where they are connecting the voltmeter. Okay. Then. So shall we do all these things for the LDR also? So now we have the light dependent resistors or the LDR. Same circuit. First a fixed resistor, then we have an LDR. So in the first one we are taking output here itself, and in the second one again we have a fixed resistor, we have an LDR, and then this time this is our V out. I don't know if it is confusing anyone. Some places I show V out with a voltmeter. I have a broken circuit here, sorry. And some places I show it without the voltmeter. Okay. So here, what is the speciality of LDRs? As light intensity increases, same as thermistors, only difference is instead of light temperature, you will have light intensity. So as light intensity increases, resistance of LDR decreases. So the resistance of the LDR decreases, and if the resistance of the LDR decreases, the output across it should also decrease. So this one is simple. And then here what happens? As the light intensity increases, what is happening again? The resistance of LDR definitely decreases. Then again, if we label this as V2, V1 and V in, V2 will decrease, but as V1 plus V2 is equal to V in, what will happen? V1 will increase. So voltmeter reading increases. So in the exams, I'm repeating, in the exams, please make sure that cross-check very clearly where the voltmeter is connected. Depending on that, your answer will change. Now in all of them, irrespective of whether you use a LDR or a thermistor or a variable resistor, in all these circuits, what is going to happen is the total resistance, they are connected in series, isn't it? So when the resistance of one component decreases, the total resistance of the circuit decreases. Okay. And whenever the total resistance decreases, the total current increases. Is that clear? So It doesn't matter which one it is. These 2 points are applicable here also, and in these 2 circuits also, where you have the variable resistor, there also total resistance decreases. Here what have we done? The resistance of the variable resistor increased. So what if the resistance is increasing? What will happen? The total resistance would increase. And because the total resistance is increasing, total current decreases. Okay, it is the same here also. So if something is happening because of which the resistance of the variable component is decreasing, then total resistance would decrease. If something is happening because of which the resistance of the variable resistor is increasing, then total resistance would increase and total current would decrease. Okay, so these are the main things about sensing circuits, where you can use a component whose resistance can be changed, because of which the voltage, the resistance, the current, all the 3 aspects of the circuit can change. What happens to the voltage depends on where you're connecting the voltmeter. If you're connecting the voltmeter across the component whose resistance is changing, what happens to the resistance? The same thing happens to the voltage also, or the voltmeter also. If you are connecting it on the opposite one, then whatever happens to the resistance of the variable component there, the opposite happens. Okay, so I hope that much is clear to all of you. Now, always having these 2 resistors, connecting them together is difficult. So in the lab, we use something called potentiometers. So all of you have used these potentiometers. Okay, so how they look like is, I'm going to show you. So this is what a potentiometer looks like, or a rheostat looks like more correctly. So what you can see here, this that you see here is one terminal, and this one is the other terminal. So say current enters then through this route, through the coils, then it will come out. Okay, so what happens if I move this here, say instead of keeping it here, if I'm keeping this here somewhere, then the current has to go through. So current comes through here and then it has to travel less distance and come out. If I keep it here, then the current comes, enters the slider. This is called the slider. And then it has to flow through all these coils and come out. So the more the distance it has to travel, more the resistance it would be having, and hence more will be the voltage. Okay, so that is a speciality of rheostats or potentiometers. So how we actually draw them is, so instead of showing 2 separate resistors like the variable resistor, we just show one of them. So this is say A, where we have the input, and say B, and then what we do is we show the slider like this. Okay, so the current can go through this and then come out. So here also the concept is the same. More the resistance of the coil, and when will they have more resistance of the coil? More the length of the coil. More the length of the coil, more the resistance of the coil. And more the resistance of the coil, more will be the voltage, or PD. Okay. Now one common exam question you will get is, they will give you a circuit diagram like this, and then they will give you a circuit diagram of a variable resistor one or a potential divider, and they will ask you which one is better. So always potentiometers are better than potential dividers. Why? Because if here I can make the resistance 0, okay, by not including any length of that coil, I can make the resistance 0, which means the voltage, the terminal PD can become 0. But in the case of potential dividers, there is always a minimum value for resistance, which means they will always have a value for potential difference also. So advantage of potentiometer compared to potential dividers. So in the case of potentiometer, the PDs can vary from 0 volts to a maximum value. Okay, so you will have a bigger range of readings. And obviously this is more convenient than having all those resistors connected and making sure of all the connections. Okay, so this is what you need to know about sensing circuits. With that, we come to the end of the lesson. In the instructions, I'll tell you which are the questions you need to try as a practice. Okay, so I hope it is clear and it makes sense to all of you. Okay then, see you.